So now we're going to do some example problems from section 3.4. Okay, so solve the exponential equation. So part of this is recognizing what powers we've got. Now, in this case, we have 3/4 to the x equals this. So what we could do is, well, what? We can't really recognize that as powers, but here's a question. Well, let's take a look. So we really don't have something good here, so could we just take the natural log of both sides? Reason being is if we took the natural log of both sides, then we could bring down this exponent using the power rule. End up just like that. So that being said, could we then divide both sides by the natural log of 3/4? Now we're going to get an answer that's going to look interesting, and then I'll explain why it looks interesting here in just a sec. So when we take the natural log of 64 divided by 27, then divided by the natural log of 3/4, we get -3. Now, here's part of the reasoning. They don't actually want you to follow this process. What they're thinking you're going to do is recognize that 3 cubed is 27 and 4 cubed is 64, but they're flipped. So what if you raised this? That means that you had to flip this fraction, right? How do we flip fractions? We make it a negative exponent, and then we cube things. So that's what they're kind of expecting you numerically to do. A lot of people may not see that, which is where this process can still work. Okay, same idea here, except, well, we could just write this as a log base 4, couldn't we? Of 256 equals x minus 1, right? Now, if you don't know what power 4 to the 256, 4 to what power gets you 256? Well, yeah, I understand. So what do? You, well, go ahead and figure out what that is, which is, sorry, 4. So it turns out the log base 4 of 256 is 4. Add 1 to both sides, x equals 5. All right, more and more. So rewrite in exponential. Now we know the base of a log cannot be negative. So when we do take the square root, all we get is 9. We don't get plus or minus 9, we just get 9. That's it. Same idea here. Exponentiate base e, or e to the 8th equals 3x plus 5. Either way works, because you get 3x plus 5 equals e to the 8th. E to the 8th is some horrible messy number, so here's what I'm going to do. And I'm going to leave that as my final answer. Much less messy than writing out what e to the 8th is. It's a horrible decimal. You can write it out, but why? Okay. Simplify the expression. Okay. So code for, look for things we can change. Like e to the, hey look, that's been composed with its, right? So that is -4 plus x to the 4th, which hopefully you recognize, in standard form. That's maybe a better answer. That's it. Natural log of e to this. Now we're subtracting it, so it's 3 minus, well, what is this? They cancel because they're composing inverses, right? So that would mean that that's x squared plus 2. That is not correct quite, because I'm taking the opposite of this whole thing, right? Yes? So when I cancel it out, I got that. So what do I get? Negative x squared, 3 minus 2, or 1 minus x squared. Either way works. All right, solve and round, and, well, here we go. Okay, first off, you have to get the exponential by itself. So divide both sides by 100. That just chops off a couple of zeros, so you get 1250 equals e to the 0.005x. Preferentially, we're going to use the natural log. Why? Because it cancels out a base e. So we're going to take the natural log of this and the natural log of this, which means we get natural log of 1250 equals 0.005x. We divide both sides by 0.005. Now they want us to round to 3 decimal places. I'll accept round or truncate, but please wait until the bitter end to actually divide it out. In this case, we get 14.179. And that's it. Okay, more solving. Same idea. Get the exponential by itself. Add 14. 3e to the x. There we go. Add 14, we get 25. Divide by 3. Take the natural log. Why the natural log? Well, if we take the natural log of both sides, equals natural log of 25 thirds, natural log of 25 thirds, which equals, give me a sec here as I type this in, 2.120, and done. Okay, what a mess. What do we do with this? Well, it turns out 16 plus 0.878 over 26 is just a number. So here's what I'm going to do. I'm going to go different. I'm going to take the common log of both sides. Am I allowed to do that? Yeah, as long as it's the same base on each side. So I have log 30 equals the log of this whole mess. And I'm just going to leave it like that. Right? So this looks kind of like some sort of, maybe some sort of compounding problem, but not quite. It's just a mess, right? So here's the deal. Why do I take the log? Because I can bring then this exponent down. So I get 3t times the log of this whole mess, which is a fancy way of saying this. Well, it's a mess, right? But it's all just one number. I'm waiting to figure out what it is because I have this sneaking suspicion I'm going to have to round, so I'm trying to avoid that. Now, I'm going to then divide by the log, meaning I'm going to get 3t by itself. And you know what? I'm going to divide by 3 at the same time. I'm going to do 2 things at once, and I'm probably not going to fall out of my chair. Watch this. Because if I divide by 3, and I divide by this, I don't want to write that out, so I'm not going to. So there. But when I do that, what happens is it's going to cancel out the 3 and that whole log thing, and it's going to get t equals log of 30 over 3 times the log of 16 plus 0.878 over 26. Now, maybe someone's thinking, hey, wait, I could bring that 3 up, and you're right. Or I could have just brought the t down and left the 3 up there, and that would have been fine too. Now, the tricky part is making sure that you put this in correctly, but it's not that bad. So you're taking the log of 30 over the log of, 3 times the log of this whole mess. So just be careful when you type it in. 16 plus 0.878 over 26 is 0.408. All that, and you get that single number. Kind of disappointing in some ways. Okay, recognize that you're looking at e to the x squared. This is the same as e to the x squared, so you can factor this as 2 linear, quote-unquote, factors, because they're not actually linear, of e to the x. How do we get a 6, but a minus 3? Minus 3 plus 2. So e to the x equals 3, or e to the x equals negative 2. Now right away, you should be able to go, does not exist, because you cannot, if you take the natural log of negative 2, your calculator is going to balk. But when you take the natural log of 3, you're just going to get the natural log of 3, which is a number, which is x equals 1.098. This does not exist because you can't take e, which is 2.718, raise it to some number and ever get a negative. This doesn't work. 74. Okay, this is e to the x squared, and this is e to the x squared minus 8. Let's do this. To make this less complicated on ourselves, what I'm going to do is I'm going to take the natural log of both sides, because I have 2 exponentials that are isolated, and then I get 2x equals x squared minus 8. Now that might work. So I bet you we can factor this. Some of this is seeing this. So I got these two things isolated. Couldn't I just get rid of this and make this a simpler looking equation? I mean, that is now simpler, right? Quadratic, so I move everything over to one side. What times what is 8, but adds together to get a 4, y negative 4 and a positive 2, right? So what does that mean? X is either equal to 4 or negative 2. So if I plug, now, are there any restrictions? Well, if I plug 4 in, I'm going to get 4 squared, 16 minus 8, which is 8. E to the 8th is fine. 2 times 8, yeah, e to the 8th is fine. Negative 2, negative 4. Is e to the negative 4 okay? And the answer is yes, because remember, e to the negative 4, which just happened when I plugged the negative 2 in, you can have negative exponents, so there are no restrictions. If this is like a natural log function to start with, that's when we start having problems, potentially. Okay, this throws a lot of people for a couple different reasons, but it has a lot to do with this fraction. You need to think of this as in parentheses, as a group. So my preference is to take the reciprocal of both sides, because it's going to be easier if I can get the thing with the thing I'm trying to solve for, that is the variable, up top. Because now I can multiply both sides by 50. Right? Now 50 over 1,000 is just a decimal. We could write it out or not. It doesn't really make a whole lot of difference. I'm just going to leave it for right now. Now I just get this exponential by itself and then eventually take the natural log and then divide by the negative 0.001. That is, in step, I'm going to get rid of the 1. Now when I get rid of the 1, right, I missed something, that negative, right? So make sure you follow that negative down, right? Then I'm going to divide by negative 2. And then I'm going to take the natural log of both sides, because that's how we cancel out the whole. Right? Take the natural log of this whole mess, yes? And then last but not least is, because now I have negative 0, 1, x. Whoops, too many zeros. Let's try that again. It's going to be negative 0.001x equals the natural log of 50 over 1,000 minus 1 over negative 2. Now, this is going to work out because this is much less than 1, and so that's going to be minus 1 will be negative, divided by negative will end up being positive. And then I'm going to just divide that whole mess outside of the natural log by negative 0.001. Now, I would recommend practicing, as in actually try to calculate it, to make sure you're putting it in the calculator or in typing in the Desmos correctly. But basically, it should match up, right? So 50 divided by 1,000 minus 1. And I'm going to need some more parentheses. So I'm going to do this way. 50 divided by 1,000 minus 1 over negative 2. Then divided by negative 0.001 is 744.440. 744.440. So that is our final answer, and you could plug this in to double check it does work. The key thing here is when you have something like this, which looks awful, right? It's got the e and everything, it's in the denominator, take the reciprocal. If you don't like that, multiply both sides by this and then divide by it. You're going to end up in the same spot. My advice, though, is reciprocal. Just make sure you do it to both sides. All right. So same thing, solving logarithmic equations. How do we get rid of the log base 9? We exponentiate base 9, which gives us 4 plus x equals 2x. Subtract x from both sides, x equals 4. That is a positive 4. We look at this, 8 and 8. No extraneous solutions. We're done. Next. Wait a second. I can do this. Because they're being added, I can combine this as multiplication. Why is that important? Because now this is a single log expression, so then I can exponentiate base. I did do just the distribution, right? So I get a quadratic, and now they like to give you quadratics that can be factored, so factoring is your friend. So we're going to have to get a minus 9 and a plus 1, which means x equals -1 or positive 9. Okay, we are going to have to check for extraneous solutions. So if I plug x equals -1 in, I'm going to get the log base 3 of -1 plus the log base 3 of -1 minus 8, which equals 2. That's a problem, right? And why is this a problem? Well, I can't take the log base 3 of -1. So this is an extraneous solution, so the only solution that works is 9. Log base 3 of 9, log base 3 of 9 minus 1 is just 9 minus 8, sorry, is just 1, so that is indeed it. Same idea. We want to combine these first. Oops, I did it wrong. Why did I do it wrong? Because I'm subtracting. So that should be the natural log of x plus 1 divided by x minus 2. Now don't panic, this isn't going to be as bad as you might think. Now I've got the natural logs by themselves on both sides, exponentiate base e, so I get x plus 1 over x minus 2 equals x. How do you solve this? Well, if you multiply both sides by x minus 2, what do you get? You get x plus 1 by itself equals x times x minus 2, and you guessed it, a quadratic happens at you. So I'm going to move everything over to this side, so I'm going to subtract x, so I'm going to get a minus 3x. Make that look like a 2. Here we go. Subtract x from both sides, subtract 1. Is this factorable? Doesn't look good, does it, ladies and gentlemen? What are we going to have to do? Quadratic formula. Opposite 3, so 3 over 2 times a, or square root of b squared, which is 9, minus 4 times 1 times -1, so it becomes plus 4 times 1 times 1 is 4, right? Over 2. So this is 3 halves plus or minus the square root of 13 over 2. Right? Now, 3 halves is 1.5 plus the square root of 13 over 2. I'm going to go ahead and figure out the 2 decimals for this because I have the sneaking suspicion we might end up with a extraneous solution. So that's 1.5 plus the square root of 13 divided by 2, which is 3.302. That's one of the solutions. And 1.5 minus the square root of 13 over 2 is negative 0.302. Do we have a problem? Well, let's find out. If I plug a negative point, that's going to be okay, because when I plug in the negative natural log of negative 0.302 plus 1 and natural log of negative 0.302 minus 2, also I can't take the natural log of that. So this just doesn't work. This one doesn't work. So my only solution that's not extraneous, right, is this, because I can take the natural log of a positive. This minus 2, that will still be positive. This plus 1, well, that's always going to be positive. So don't forget to check for extraneous solutions if your equation starts off with log or natural log. And that concludes our example problems, finally.